Hey guys, in this video we're just going to look at the first part of lesson 4. So we have a do now here that says a standard die is numbered 1 through 6 is rolled. Find the probability of a single roll getting a 2 and an odd number. So let's think about that sample space for a second. So rolling a die, our sample space would get us 1, 2, 3, 4, 5, or 6. Okay, so those are the 6 potential options of rolling a dice. So each of them have an equal shot of 1 out of 6. Now, we're looking at 2 separate events here. So I want to think about that for a second here. Rolling a 2 and rolling an odd. So if I was just to categorize these numbers here, well, we know rolling a 2 is the only thing that could get us a 2. So that's a 1 out of 6. While rolling an odd number could be 1, 3, or 5. So that's a 3 out of 6. But there's no way both of these events can happen. So if there's no way they can happen, it's a 0 out of the 6. It's an impossible event. So that's 0% or 0, however you want to think about that, but it's impossible. We actually refer to that as being mutually exclusive. So anytime you're looking at 2 particular events, if there's no way to get an and or an overlap, then they're mutually exclusive of one another. So that's because it was a single roll and we saw that word and, right? That's where the 2 things both have to happen. So in this case, the and can't happen, okay, because there's no way to get an odd number if we have to roll a 2. 2 isn't even. So there's no overlap between the 2 of them, okay? And if 2 events are independent, then we know from lesson 3 that the probability of A given B is equal to the probability of A. Now we're going to use that idea to kind of develop some other way to test independence here today. So we do have to think about our conditional probability that we saw in lesson 2 and that continued on to lesson 3 for us. So you know, A given B means that A and B happen over that given of B. Well, let's say I cross multiply that idea for a second. So I stick that over 1. So we have P of A given B times P of B equal to P of A and B. Now, think about what it means to be independent of one another. If we have 2 independent events, then it doesn't matter what the given is, it's just going to equal P of A. So, if I take this idea here and I rewrite P of A given B with just this piece here, this P of A, well, that means that P of A times P of B is equal to P of A and B, which should be true. So our other way of testing independence is here. If you take the probability of A times the probability of B and it equals the probability of A and B, that's just another way we can test. So let's try that out in this first practice example. So I'm given this two-way table about a group of students at a high school that took a standardized test. The number of students who passed or failed the exam is broken down by gender. So first we have to fill in the table. You always need the totals when you're finding the probability so you can set up those probabilities properly. So I'm going to add up the males. I'm going to take 108 plus 36. And when I add those 2 things together, we get 144. And then we're going to take 78 plus 26, we're adding up the females, and we get 104. Okay. If I add the total of passing, I'm going to take 108 plus 78, and we get 186. And we add the fails, 36 plus 26, we're looking at 62. And you can add in either direction with those totals to get the total amount of participants. But when we do that, I'm looking at 248. So now I have all the totals shown. When I have all those totals shown, we are able to set up our probability. So let's try this new method that we referred to here. So we have the probability of gender passing the test. Now again, you can pick either gender you want. So I'm going to just try the males out for this particular exercise. So the probability of being a male times the probability of passing, if they're independent, will equal the probability of being a male and passing. So let's set up those particular probabilities. So first, total of males 144 out of 248. Times the probability of passing is 186 out of, again, the total was 248. And it's going to equal male and passing. So that's going to be the 108 out of the 248. Now I'm going to let the calculator do the work for us because it did take it around to the nearest thousandth. Definitely not expected to know those calculations off the top of your head. So we're taking 144 divided by 248 times 186 divided by 248. Be careful plugging into the calculator. Either use your alpha y equals, use parentheses, but just make sure when you're plugging it in correctly. When I round this left side to the nearest thousandth, I'm looking at 0.435. Okay, and then when I take 108 divided by 248, well, we end up with the same exact thing rounded to the nearest thousandth. So these two events are independent of each other. If they were not equal, then you could say they're not independent. Okay, because this is a test for independence. Now, for the second page here, I want you to